This is a continuation of the previous video. For the previous video, using the same equation, only focused on the solution of the integrating factor needed for this video. Now, you would like to review that if you would like to, because this is very important, as in the previous video, we're able to identify the integrating factor mu x is equal to x to the power of negative 4. Okay, this was the integrating factor on the previous video. Again, if you're not convinced with this, try to review that. Actually, we started with the idea of coming up with the standard form of this. We multiply both sides with 1 over x because there is x here. So you have dy over dx minus 4 over xy is equal to x to the power of 5 now, because you're going to cancel one of which here, times e to the power of x. We repeated this process because this is very important. This is our f of x. X to the power of 5, e, that's e to the power of x. Of course, this was our p last time, the function we used in order for us to come up with this integrating factor. So again, we'll be using the integrating factor and this function of x in our solution, or the next steps of this task. We have here this expression, mu of x times y is equal to the integral of the same integrating factor but product with f of x and then dx. So let's try to input all the notations here. So you have x to the power of negative 4y, that's our left hand side. For our right hand side, you will have here x to the power of negative 4, and then you will have here times your f of x, which is x to the power of 5 e to the power of x dx. So with this now, we can see that we can combine these two. So you have x to the power of negative 4y is equal to the integral of x e to the power of x dx. Okay? But this cannot be integrated directly because we cannot express one as part of the derivative of the other. Let's say for example, let u is x, so its du is dx. So none of here is e to the power of x, right? If we are going to let u be e to the power of x, its du is e to the power of x dx as well. So there's no coefficient, or there's no function with x as its variable. Hence, this is a clear indication that we are going to use here integration by parts. And as well as discussed before, there are considerations as to which function will be used as u and the other would be dv, because we have that acronym or mnemonic LIATE. In this case, we're going to let u be our x, so our du is just simply dx. That would mean dv is e to the power of x dx, dx. And if we're going to integrate that, integrate dv, integrate e to the power of x dx, our v is just e to the power of x. Of course, plus c, but we don't need that in the meantime. We'll be using all of this because let's just pause for this side. Let's just simply continue, integrate this by parts. This is our u, the integration of u dv is equal to uv, that's u v minus the integral of v du. So your u here is x, your v is e to the power of x, minus the integral of your v, which is e to the power of x, and then du, you have your dx. And since we already have this is actually equal to x e to the power of x minus e to the power of x. So this is the integral of the entire expression here. Okay? So you will have to resume now. X to the power of negative 4y is equal to x e to the power of x minus e to the power of x. And by the way, since you're integrated here, you can have plus c this time. So plus c here. Now, to complete this, we would like a solution in terms of y. Y is equal to something. So we can actually, let's just continue with another step here. Let's factor e to the power of x. So you have x minus 1 plus c. Now it's easier for us to multiply both sides by x to the power of 4. Why x to the power of 4? It's because once we multiply that, that's x to the power of 0, y, which is just equal to 1y. Okay, so basically you have this form here, e to the power of x times x minus 1 plus c times x to the power of 4 as the same here. Or you are, yeah, let's just simply write that here, x to the power of 4. So let me redo all of these things here. Okay, again, x to the power 4 times x to the power of negative 4, x to the power of 0 or 1. So we are left with y is equal to, the last answer or the last form would be x to the power of 4 e to the power of x times x minus 1 plus c x to the power of 4. This is now the solution of our given equation. Take note that again we use the integrating factor presented in the previous video together with the f of x here when this is already in standard form, and we illustrated the integration by parts for this specific integral because it cannot be automatically simplified. So by the way, this is for this video. Thank you very much for watching.